boring old Git, and today we're going to try and get some disk drives working for the HP9123H that I've just restored. First one up is a 9133H, so this is a single floppy plus a 20 megabyte hard drive. Communicates through GPIB using the SS80 protocol. I'm trying the floppy disk here, and this looks like it's going to be the big problem with this restoration. It's not going in very well, and this is me fighting to try and get the floppy disk out. It is a well-known problem with these that the floppy disk loading mechanism gets gummed up. The grease dries out, and then the mechanism won't properly load or properly release. Other than that, the unit seems to be in pretty good condition, though there is a little pause for thought with the label that's on the top. It's been peeled, so I can't read it. The unit was listed as being in working condition, but I suspect that all that means is it's been plugged in, powered up, and there was no smoke and the power light came on. So the first stage of the process is to get the lid off the unit and have a look, see what we've got inside. I was a little bit concerned because as I was moving the unit around, I could hear something rattling inside. I really was hoping that it wasn't the hard drive that was damaged. The lid's held on with 3 screws, as you can see, and then the cover just slides off. There we go. And then once that's off, we can see everything inside. It doesn't look too bad in there. It looks pretty clean on the surface, but knowing that the grill is at the front bottom and everything is drawn in, I'm expecting that the hard drive, the power supply, and possibly the inside of the floppy disk drive are going to be particularly manky. Particularly when we know that the floppy drive is gummed up. So I finally tracked down what was rattling inside the unit, and it turns out to be one of the heads out of the floppy disk drive. Fortunately, nothing to do with the hard drive, but it does mean that we need to do some major repairs to the floppy. Anyone who watched the first video I did of the broken protocol analyzer will recall that that had fried electronics. So I thought I would try taking the top head from that floppy drive, since I knew it was junk, and transplant it onto this drive. I didn't have any great hopes that it would work, but I thought it was worth a try. So I'm harvesting the head off that floppy drive and transplanting it with the head support spring onto the carrier for the floppy drive that is missing the head. It looked like it would work. When I measured the two heads, they had similar resistances, they had the same layout of connection. But also, they're both the same specification of head. So they're both heads for a 720K floppy drive with a 600 RPM rotation speed. So I thought it was a pretty safe bet that it would work if I could get the heads correctly aligned relative to each other. So there was a lot of taking apart, putting back together, trying to get the floppy into a workable condition. I probably spent best part of 2 or 3 weeks working on this. Unfortunately, by the end of it, it wasn't successful. I may do a further investigation of the floppy drive just to see if I can see anything, but I'm not overly confident. What I was finding when I tested the drive is the output signals, when I had it on a test bench, looked good. They were the right sort of frequency, the right sort of shape. But unfortunately, I couldn't see any difference between the signals with no floppy in the drive, a blank floppy in the drive, a formatted floppy in the drive, or even with the drive ejected. This suggests to me that either the heads aren't actually making connection at all and the amplifiers are just picking up noise, or that there's a wiring problem, or possibly even that the electronics on the floppy drive are also faulty, which is entirely possible. It was at this point I decided that I was going to cut my losses and replace the floppy drive with a Gotek. So enjoy the rest of the montage while I try and fix it, and then we'll move on to installing a Gotek. So this is the setup for the Gotek. It's one of the newer and cheaper models with the artery controller instead of the STM32. I decided that rather than modifying the floppy disk cable, I would make an adapter that plugs into it so I can go back to the original floppy drive if I get it working, or if I get hold of an equivalent. So the little table at the top left of the picture shows the wiring connections and how the 26-way cable on the 9134 maps to the 34-way cable on the Gotek. There are two signals that are not supported on the Gotek interface directly. The head load signal, which isn't required anyway because the heads are automatically loaded, and then the disk change reset. More modern floppy drives reset the disk change signal on a valid access to the drive. The older ones require an explicit reset signal. Because this isn't on the bus, it is supported by flash floppy, but you have to connect directly to one of the pins on the board. In this case, the software clock for the debug and programming circuit. So that's what the purple wire does, and then it's set up using an option in the software. The only other thing of note is that I've implemented 3 LEDs on the front of the floppy drive replacement. One is a power indication because there isn't actually a power indication on the unit. The second one is a drive activity light. Unfortunately, you can't use the drive select signal, so you can't use the provided LED because the drive is permanently selected. So what I've done is I've hooked that directly onto the motor on signal. So the access light illuminates every time the floppy drive motor is turned on. The other LED, which is the lowest of the 3, is hooked onto the right gate signal. so that lights up whenever you try and do a write to the floppy drive. It just gives a little bit of extra indication of what's happening. All that's left to do with the 9133H now is to turn it on and see what happens. I've boosted the audio just so you can hear what it sounds like when it's booting up. For the eagle-eyed among you, you'll see that I've changed the colours of the LEDs on the front of the unit. The original colour scheme of yellow for fault and red for drive access didn't sit well with me. So I've modified it now to give red for fault and green for drive access. So now it looks like we've got a functional HP9133H. Let's move on to the HP9122C. So this is the HP9122C. It dates from about the same time as the 9133H and also the 9000/332. It's a GPIB based dual floppy drive. The C model is the latest of the models and it provides two 3.5-inch 1.44 megabyte floppy drives. The D version, which is the slightly older one, only provides 720k of capacity, but the trade-off is that the D runs at 600 RPM while the C runs at 300 RPM, so the double data capacity is gained at the expense of half the operating speed. It was sold as faulty, and when I started checking it over to power it up, I found the fuse was blown. This was a little bit of a concern because the fuse was 6.3 amps. This is the wrong size for the unit and makes me wonder whether it was set to 110 volts rather than 220. If it has and the machine's been run at that, then it's entirely possible that something inside will be blown. So it's open it up, take it apart, and then start trying to find out what the problem is. So to see if there was any damage, I started belling out the high voltage side of the transformer. What I found was that the resistance was higher than I expected for a transformer of this size. So I started going round the circuit. Here I am looking at the voltage selection switch and actually measuring across the terminals of the switch. Where I was expecting to be getting pretty much nothing, fractions of an ohm, I was finding that the resistance was actually well up from that, tens, hundreds of ohms even. Certainly not a good situation when you're putting mains through the thing. I think it would get very hot very quickly. given this is the state of the voltage selector switch, then I think I'm glad that the fuse had blown. So I pulled the switch out, got it on the bench, and here I am actually physically opening it up to see what sort of state it is inside. So it's a simple snap together switch, and in the worst case I could just throw it away and hardwire the voltage selection, but I wanted to keep it and see what sort of state it was in. So it's a matter of lifting the housing over the tabs on the base. There we go, and out it comes. And immediately you can see that the contacts for the 220 volt side are black. So what I think's happened is that it was plugged in while it was set to 115 volts. Somebody's realised and thrown the switch over to 220 volts, and this has caused arcing at the contacts. The sudden surge through the transformer as the voltages settle has caused a surge of current which has blown the fuse and also contributed to the arcing of the contacts. It's out with the fiberglass brush, clean all the contacts, lubricate them with a switch cleaner, then reassemble the switch and get it soldered back into place. Then we can start testing to see if there are any other problems. So now the switch is back in, it's time to test the voltage rails. So going through them in turn, -12 looks good. +12 looks good, and +5 looks good, so everything looks optimistic. I can't see anything burnt on the board, so all the outrage and damage looks like it might have been limited to the fuse and the voltage selector switch. So I'm dropping the fan back in, which unfortunately is a custom fan. If you can see, it's got no cowling and mounts via its hub. I'm assuming this was some sort of cost saving measure because I can't see any space saving reason for it. The last test is to see if that spins up correctly, because that'll prove that the 24 volt rail that it runs off is good, and that's the last of the power supply rails to be checked. And there we go. That looks good. That seems to be running well. So we can move on and see if it'll power up once it's reassembled, and then whether it'll pass the self-test. So I've mounted up the floppy drives and reconnected them. And here I am testing them with no floppies in the drives. This was the first time up. I can see drive 0 did a seek test. I didn't see drive 1 do a seek test, and the fault light stayed on. I sat around a little bit to see if the light would go out subsequently, but it resolutely stayed. So what I did was, just to check things out, I popped the tops off the floppy drives and redid the test with floppy disks in the drives. Both drives did the seek test, and the fault light goes out. So next thing to do is repeat that with the floppy disks removed. They're flopping around because they're not screwed in, because they need to be stripped and cleaned and the front's retrobrighted, but there's no point doing that until I know they work. and with no floppies in, they both do the seek test, and then the fault light goes out. This is a view of the front as I received the unit. As well as having some horrible stickers on it, there is an awful lot of yellowing on the front of the floppy disks. So the first thing to do is to strip those covers off and get them into the Retrobrite. Here's the cover of drive 1. I used some sticker remover to get the stickers off, and as you can see, it looks an awful lot lighter than it did. What seemed to happen was that the sticker remover dissolved the adhesive for the stickers, but it also seemed to attack the top surface of plastic on the cover. You can see a scratch mark, which is where I caught it with my finger. It had softened the surface that much. But what's interesting is that it seems that the discoloured plastic is more susceptible to the solvent than the undiscoloured plastic. And wiping over with the sticker remover has actually taken off a lot of the discoloration, though it has slightly affected the surface finish and made it somewhat shiny. Though I did find that running over the front with some Jif scouring cream helped to reduce that effect, and now the cover looked almost indistinguishable from the original. So what I've done is I've put the items to be retrobrited into the bottom of my UV exposure box and given them a good generous coat of 40 volume hydrogen peroxide cream. I'm using cream rather than liquid because it's easier to handle. The parts then have gone under the UV light and I've retrobrited them for around 4 or 5 hours. That seemed to give a pretty good bleaching and everything seemed fairly uniform. And the front side of the covers match the rear side now. So let's boot the thing up and see if it works. Powering on the main unit, the drives are already powered up. It's going through its SelfTest and then it's set to auto boot into basic. So here's the boot up message. The actual boot process takes about a minute, so we'll hop over to the end. Okay, we're into basic. So first thing is doing a directory of the hard drive. So that's the cat command. Colon because we want to look at the root. Comma 701 says HPIB address 1, and then comma 0 indicates that we want to look at the first volume. Same again, comma 1 is the Gotek drive on the 9133. This has got nothing in it, so it's giving the correct response. Then cat, colon, looking at the root, 702, comma 0, so this is drive 0 on the 9122, so the first floppy, and it's got a 16500 logic analyzer test disk in it. And doing the same again for the second drive, drive 1. And this one has the boot disk for the 16500 test. So everything looks like it's working. We've got a functional retro workstation. All I've got to do now is get some instruments and things for it to control. Thank you all for watching. Don't forget to like and subscribe. Please leave me any comments, ask me questions, and give me feedback. And I look forward to seeing you with the next video.